So this is take 2 for this recording of this Unit 10 portfolio recap. Because my headphones actually, I have a pair of wireless headphones and they kind of died in the middle of the recording and I didn't notice it until after the recording was over. But this recording is to help you go through the Unit 10 portfolio assignment, for you to check your work on it and to hopefully make any corrections you need to make before turning in the assignment, and also should give you an idea of what you might need to review a bit more before you proceed to take the test for Unit 10. So let's get into the portfolio problems. So we studied polygons in this unit, and one of the first things we learned about was the polygon angle sum rule. There's also an exterior angle rule as well. But for this particular set of problems, doesn't really apply here because of the fact that for me to really make good use of the exterior angle rule, I would have to know the measurements of a lot of the other exterior angles, and I don't have any exterior angle measurements at all on this. I'm looking for one in B, which is Y, but I don't have any of the other exterior angles, so I'm not going to be able to use that one. The rule that we're going to be using for this to help me figure out what X is in both cases is that the sum of the angles in a polygon should add up to be n minus 2 times 180, where n is the number of sides. So that's a formula we use. So for part A, we do have a hexagon there. It has 6 sides, and therefore if I add up all the angles on the inside, it should total 6 minus 2 times 180. And so when I simplify this, x plus 632 should equal 720 degrees total, which means x should be 88 degrees. So when I go over to B, the figure I have there is a pentagon, which means that if I add up all the angles on the inside, it should total 5 minus 2 times 180, and therefore x plus 441 should equal 540. And if I subtract 441 from both sides to find x, I would find that x equals 99. Now, as far as finding angle y goes, well, x and y are a linear pair, and that's going all the way back to Unit 2. But we do know that linear pairs are supplementary. So I know that 99 plus y should be 180, and that means that y would have to be 81. Now, going over the problems like this, like they tend to be, when I'm given these measurements of sides or measurements of parts of diagonals or segments or angles, whatever they may be, these types of questions are exactly the same. That is, I am looking to establish some equation that involves the variable in question. And so I could solve that equation, figure out what x is in this case, and if need be necessary, I could even go back and figure out what the various lengths are by substituting the value I find in for x. So ultimately, what I'm looking to do in these cases, now how I set up that equation is based off of me knowing characteristics about whatever it is I'm dealing with. So in both of these cases, we are told that the figure is a parallelogram. I mean, they're told you it's A, B, C, D, but they don't have the markings to let you know what A, B, C, D are. But besides the point, I have enough information knowing that these are parallelograms, and because they are parallelograms, I have to use a characteristic of them to help me figure out how I'm going to set up this equation. For A, since I'm looking at the lengths of the sides of the parallelogram itself, I have to use a rule associated with that. And one of the rules that we do have is that opposite sides of a parallelogram need to be congruent. I mean, there's also a rule that says opposite sides have to be parallel, but parallel often only helps us figure out information regarding angle measurements. So being parallel doesn't help us here, but then being congruent does, because that means that either 2x is going to equal x plus 8, 4x is going to equal 3x minus 16. Now, of course, it's set up that either one of those two equations should give you the value of x that's being sought. I chose myself to use the fact that 2x equaled x plus 8. So with that being said, I just solved this equation by subtracting x from both sides, and I get that x equals 8. Now for b, all of those are representing measurements of diagonals in this parallelogram. Not the entire diagonal, parts of the diagonal. So basically, the 4x minus 6 is going from one corner to the center. The one that's marked x is going from another corner to the center. The one marked as 2x is going from yet another corner to the center. And then, of course, same thing with the 6x minus 15. So I have to use a rule that's involving, measurements that are involved with the diagonals of a parallelogram to set up my equation. So, and then I had to go through those rules and say, well, the rule I'm going to be using here is the fact that I know that in any parallelogram, the diagonals should bisect each other, which means that where the two diagonals intersect each other, that should be a midpoint for each one of those two diagonals. So that means that 4x minus 6 should equal 2x, and x should equal 6x minus 15. So I could use either one of those two statements as my equation that I need to solve to figure out what x is. So in my case, I did choose that x was equal to 6x minus 15. And then I solve this equation. So I subtract 6x from both sides, and get that negative 5x equals negative 15, and I divide negative 5 on both sides, and I get that x equals 3. Now for this one here, they say classify each quadrilateral as precisely as possible. And that's just using the markings here. There's questions like this, asked kind of slightly different variations throughout this entire unit on quizzes and tests. One of which, and I'm going to kind of mention this as a side. It's not really relevant to this particular question, but I want to make it known out there. There's a question that I've seen it's one of the quizzes or the tests. I can't be sure which one it is off the top of my head. I think it is on the test. That's why I want to mention it here, so that helps you prepare for it. If the question is phrased, it says essentially, describe whether the information classifies the quadrilateral as a rhombus, a rectangle, or a square. And a lot of students make a mistake on that particular problem by thinking it's a process of elimination. I'll have students that'll say, oh, it's a rhombus because it's not a rectangle or a square. That isn't what it's asking, because it's asking, describe whether or not this can be described as a rectangle, a rhombus, a rectangle, or a square, which means that there's another option. It could be neither of them. So if you're going to state that a figure is any one of these things, whether it's a parallelogram, whether it's a rhombus, a square, even trapezoids, kites, whatever it may be, you need to establish characteristics, of that particular figure somehow. And it's based off of those characteristics that you should be using to state whether it's a rhombus or a square. It isn't a process of elimination where you say, okay, I ruled out these, therefore it has to be this one. No, it doesn't. It doesn't have to be a parallelogram at all. It could be just a regular quadrilateral. So it could end up being just a trapezoid instead of any kind of parallelogram, whether it's a rhombus, rectangle, square. It may not even be a parallelogram. So make sure that you are finding a way to establish, based off of information that you're given or information you're able to find, about what characteristics it's meeting for whatever figure it is you're defining it as. Don't just say, well, since it's not one of these, it has to be this. That's not the case. Okay, so and there's a question like that even though like most students guess correctly because of that process of elimination, based off of the grading rubric, you get very few points for it because you came up with the right reason, the right answer, but have the completely wrong reason for choosing it. So, but getting back to this question here, we're looking to see what characteristics are being met here so we could classify the quadrilateral. Um, when I look at A, I have all four sides being congruent to each other, which means opposite sides are congruent automatically. So it's definitely a parallelogram. And since all four sides are exactly the same, it's a rhombus for sure. I don't see any indications of right angles. So that's as far as I can go with it because I can't classify it any further, like such as a square or anything. So this thing's a rhombus. When I look at B, again, I have opposite sides being congruent to each other. So it's definitely going to be a parallelogram. I see the right angles indicated, which means it's definitely a rectangle. I don't see any indication that all four sides are congruent. As a matter of fact, this thing's communicating in a couple of ways that it's not the case. I mean, the horizontal lengths look much longer than the vertical ones, but you shouldn't use that solely as a reasoning because of the fact that, you don't go by appearances. What's even more of a strong piece of evidence is the markings. The two horizontal sides are being marked with, a double tick mark. The vertical ones are being marked with a single one. That's a clear communication in this problem that we are assuming that those are different measurements. So the evidence I have actually leans towards each pair of opposite sides having different lengths. So the best I could call this is a rectangle. For C, I do have one pair of opposite sides being parallel. I don't have any indication that the other sides are supposed to be parallel, and they certainly do not look like they'd be parallel. I mean, if I extended them, it looks like they would eventually intersect. So at the best I could call this, because I have one pair of parallel sides, would be a trapezoid. For D, I don't have any pairs of opposite sides being congruent. What I do have are two pair of consecutive sides being congruent. And when I have consecutive sides being congruent and then another pair of consecutive sides being congruent, that's an indication of it being a kite. For E, I have a couple of things in here. I had the diagonals in this being perpendicular to each other. Now, for a quadrilateral, that could either make it a kite, or if it happens to be a parallelogram, it would make it a rhombus. So I had to find a way of determining which one of those it is. Now, I have students that will somehow say, well, all four sides are congruent. There's no indication that the four sides are congruent because, I mean, people would lean towards rhombus on this one. And so would I, but here's the actual reason as to why it's a rhombus. I can see that, since I'm down to either it being a kite or a possible rhombus, if I could establish it also as a parallelogram, then it would be the rhombus. And in this case here, I do see that the diagonals are indicating that they're bisecting each other because the two diagonals do intersect at each other's midpoints. So that means that the diagonals do bisect each other. That makes it a parallelogram. And because it's a parallelogram that has the diagonals being perpendicular, that makes it a rhombus. The last one, I have all four sides being congruent, which means opposite sides would automatically be congruent. So it's definitely a parallelogram. Since all four sides are congruent, it's also a rhombus. And the fact I have indications of right angles, that would indicate it's a rectangle, because it's a parallelogram with right angles. But since it has characteristics of a rectangle and a rhombus, that makes it a square. Back to these types of problems, again, these are situations where I should be able to get numeric answers. I still have students that will say like, okay, like, solve for, I'm going to solve for X. And they say, oh, 3x equals this, and that's all they do. That's not the answer. Because not only can I find out, what X and Y equals in both of these cases, I can figure out what the angle measurements are for these angles as well based off of the things that I know about the figure. In A, it's a parallelogram, and I can see that because of the markings. The markings are indicating that both pairs of opposite sides are parallel to each other. So if I have two pairs of opposite sides being parallel, that's the basic definition of a parallelogram. Now, since I know it's a parallelogram, there's other characteristics that are involved with it, and one of the main characteristics I'm going to be using for A is to find X. Since I have one angle being 3x and its opposite angle being 2x plus 19, I have a characteristic about opposite angles for parallelograms, and that is that opposite angles have to be congruent, i.e. have the same measure. So I know that 3x should be equaling 2x plus 19. And by simply solving that equation by subtracting 2x from both sides, I do get that x equals 19. So I got x. Now to find what y is, well, for y, I don't have anything else that I don't have the measurement of the opposite angle written in terms of y or another number or what have you. So that's not going to be helpful. But I also know as another characteristic of a parallelogram is that consecutive angles are going to be supplementary. That means that the angle should total 180 degrees. So either 3x plus y should equal 180 or 2x plus 19 plus y should equal 180. I chose that one. And the fact that I know that x equals 19, 2 times 19 would be 38, so y plus 38 plus 19 would equal 180. And I basically just simplify and then solve for y to get it as 123. And I do something very similar for b because although I'm not told that opposite sides are parallel, opposite sides are congruent, and that is another theorem that tells me that this thing is a parallelogram. And since it's a parallelogram, it's going to have characteristics of a parallelogram. And again, the characteristic I'm focusing my attention on is that opposite angles are going to be congruent to each other. So 3x and 2x plus 33 should be the same measurement. They should equal each other. And when I subtract 2x from both sides, I get that x equals 33. Now, along with that, much like I did in the previous one, consecutive angles should be supplementary to each other. So either 3x plus y equals 180 or y plus 2x plus 33 equals 180. That's the one I went with, but I already substituted in for the x as well because I knew x was 33. So y plus 2 times 33 plus 33 should equal 180. That means that y plus 99 is 180, which means that y would be 81. They give you some things like this that have you kind of draw the figure. Sketching the graph certainly does help with this. They ask some questions like this on the tests and quizzes as well. Obviously, you're not going to be able to submit a graph on all of them, especially if it's just an essay question and not a web work question. So, but we want to be able to determine the most precise name for the quadrilateral. So again, you know, if it's a rhombus, we don't want to say it's a parallelogram. Rhombus is a more specific type of parallelogram, and a square would be even a more precise definition or characterization of that figure because that's a special type of rhombus. So, so we want to be able to see what kind of characteristics we have, and we can't go based off of appearance. We need measurements. We need side measurements, or we need to determine parallelness, or the measurements of diagonals, whatever is needed to do it. So now I do draw the figure because to give myself some orientation for it, because one of the things I'm going to need to know is if I'm mentioning side measurements, I want to know what the sides are. If I'm mentioning diagonals, I want to know what the diagonals are. So I want to be able to see what those are. And that's what the figure looks like, and this looks like kind of like a rhombus, but that's not good enough for me to do that, because who knows? I mean, I drew my graph as carefully as I could, but my scaling might be off, and what looks congruent may not actually be congruent. So, so I'm going to make some characterization. It's definitely a quadrilateral. That's all I know so far. I do have the fact that I can see that I have two sides that are vertical to each other. So I can say right now that one pair of opposite sides are parallel to each other because they're both vertical. They have the same x coordinates at A and D as well as B and C. So that would indicate they're both vertical, and if they're both vertical, they're horizontal. I mean, they're not horizontal. Vertical's horizontal. That's silly. They're both parallel to each other. Um, I'm not going to use any slopes on this, but I certainly could use slopes to determine that A, B, and D, C have the same slope. I'm not doing that here. I'm going to use something else to establish anything about it, but the fact that they clearly are not horizontal, at least I can say that there's no right angles involved in this quadrilateral. And with that being the case, I can rule out square and rectangle for certain. That doesn't mean that it's automatically a parallelogram. It doesn't mean it's automatically a rhombus. It just means I ruled out square and rectangle. And that's what the first thing says here. There's no right angle, so it's not a rectangle, it's not a square. What I chose to do is I took measurements of all the lengths. I mean, measuring AD and BC is pretty easy because all I have to do really is be able to count. Both of those are 5 units long. When I use the distance formula for AB and CD, I get that they are also 5 units long. So with that being the case, I know that all 5 sides of this, or all 4 sides of this figure has a length of 5. Which means that I definitely know it's a parallelogram because opposite sides are congruent to each other. I do know that it's a rhombus because all 4 sides are congruent to each other. I've ruled out rectangles and squares. It's not going to be I can't classify as a trapezoid or a kite because I already know it's a parallelogram and a rhombus. And so rhombus is about as precise as I'm going to be able to get on that. So that's what I'm going to call it. It's going to be a rhombus. So because of that, it's a rhombus, and that's the best characterization I have for this particular quadrilateral. In number 6, we are told that these are both trapezoids, and so I'm looking for particular characteristics of a trapezoid. In this case here, it wants us to find xy. Now, as you can see in figure A, xy is what we would call the mid-segment of the trapezoid. We talked about mid-segments of triangles back in Unit 7. Well, here we're talking about mid-segments of trapezoids. In B, I can see that xy is one of the bases of the trapezoids, and at ST, looks like it's the mid-segment based off of definition because it's connecting the 2 midpoints of the legs of the trapezoid. So I'm going to be using the same formula in both of these cases, just a little differently, because we do have a rule that says that the length of the mid-segment of a trapezoid equals 1/2 the sum of the lengths of the 2 bases. So for A, I know that one base is 16 units, the other base is 8 units. That means that xy should be 1/2 the sum of those two. And that would be 1/2 of 24, which is 12. So xy is 12 units long. For B, I'm not looking for the mid segment, so I'm not going to set up that xy equals 1/2 the sum of these things. And that's a problem that students have is they set it. I mean, no matter which one is the missing piece of information, they set up exactly the same as if they're searching for the mid segment. I know what the mid segment is. The mid segment's ST, so I know that 15 should equal 1/2 of the sum of 6 plus whatever xy is, which means that xy plus 6 should equal 30, which means xy should be 24 units. So make sure that when you deal with problems dealing with mid-segments and you're looking for lengths that you have adequately set it up the correct way. Otherwise, you can end up setting it up incorrectly with the right idea, but just setting it up incorrectly and end up with the wrong answer. They're telling us here that this is a kite. So I have to look at the characteristics of a kite. Although there's no formal proof of it, kites are going to have one pair of opposite angles that are not congruent and another pair that are. Okay, and that could be easily established by using triangle proofs, because it's really typically easy to take a kite and put in an auxiliary line to show that by side, side, side you have congruent triangles. And if you have congruent triangles, you're going to have a pair of corresponding congruent angles by CP2TC. There's no formal proof of it, but I mean, if you just keep going through them again and again and again, you will see that in a kite, you're going to have two angles that are congruent, two pair of opposite angles that are congruent, and the other pair will not be. So since I am given one pair of opposite angles in this kite being 101 degrees and 48 degrees, those are the ones that are not congruent. That means that angles 1 and 2 are congruent. And if they're congruent, that's also going to be helpful to me, because now at this point, I can use the fact that, it's a kite, but it's also a quadrilateral. And the four angles of the quadrilateral should total 4 minus 2 times 180, or it's going to end up being 360. And since angles 1 and 2 are congruent to each other, I can replace either the measurement of angle 1 with another measure of angle 2, or vice versa. That's what I did, is I replaced the measure of angle 2 with another measure of angle 1. So I have 149 plus the measure of angle 1 plus the measure of angle 1 again. That should total 360, which means 2 times the measure of angle 1 plus 149 should equal 360. I subtract 149 from both sides, and I divide both sides by 2 to get the measure of angle 1 is 105.5 degrees. And as a result, the measure of angle 2 is also 105.5 degrees. Of course, we're still dealing with proofs here, and as you deal with proofs, again, we still have to remember a lot of the other rules we did from previous units, but we also have to make sure that, whatever statements are going on here, if we're asked to provide a statement, if there's a reason associated with it, it's supposed to help us figure out what it is, then, we need to make sure that, that what we're telling is going to be the result of me being able to state that reason. And then, of course, vice versa. If I'm given a statement, I want to provide a reason that makes sense in context of where I am in the problem. Again, as I do this proof, kind of going back to some things, the fact that triangles EFK and GHK are supposed to be congruent, that's something I'm looking to show. It's next to the word prove, so that's not given piece of information, and I don't know it's true, so I can't use that those are congruent for me to make any kind of other statements in here. The statements I make in here should lead me to the conclusion that those two are congruent to each other. So for number 1, it's looking for a statement or statements, and it says, okay, the reason is that it's given. Well, the given piece of information is that I do have a parallelogram EFGH. And it's important to know it's a parallelogram because it's going to have characteristics of a parallelogram, and I want to make sure I'm able to use those. And it says it has diagonals EG and HF. And that's also going to be helpful because, I know what the diagonals are, and I know there's some characteristics about diagonals in a parallelogram that might be useful as well. So that's the given pieces of information, and I'm just going to restate that for the given piece of information. Now for number 2, it says the diagonals of a parallelogram bisect each other. That's actually a theorem. That's actually one of the characteristics that we know about a parallelogram. What's that going to help us do? What's that going to help us find? What does it mean to bisect? Okay, well, if they bisect each other, that means that when I look at segment EG, one of the diagonals, that means that K should be the midpoint. That means that EK and GK should be the same measure. And I should be able to make the same kind of conclusions with diagonal HF, in that HK and FK are the same measurement and congruent to each other. So I'm able to make those two statements, and notice I'm also marking them because I'm ultimately looking to see that triangle EFK and GHK are going to be congruent to each other. These do happen to be sides that I'm marking here of those two triangles, so it's very useful for me to have that piece of information. Now there's a couple of different routes I could go on this. I could prove that some angles at the vertex K are congruent to each other by vertical angle theorem. Like, for instance, I could say EKF and GKH are congruent by vertical angle theorem. And I could prove the two triangles I'm looking for at that point would be congruent by side angle side. And I'll have students that'll do that, but they're not following along with what the proof in front of them is saying, because the proof in front of them is saying, okay, EF is congruent to GH. Okay, so we're basically saying that these are congruent to each other. Those happen to be opposite sides of this parallelogram. And again, this little symbol here that I have, if I have this symbol in front of 4 letters, that indicates parallelogram specifically. And therefore it has the characteristics of a parallelogram. So I can state that those two are congruent by the fact that opposite sides of a parallelogram are congruent to each other. And also notice that I did mark up there that, they're congruent by putting markings in up there. That's helpful because, I'm on my last statement. We're on statement 4. That should be easy to know what that statement should be, because if this is the last statement in my proof, it should be the thing I'm looking to prove. So it should be the fact that triangle EFK is congruent to triangle GHK. Now the thing I'm looking to do is figure out, well, how am I going to know that based on what I've already established? And what I established here is I can see that those 2 triangles in question each have, sorry, I had to cut there for a second, loud kids in the background. So, but as I was saying, I can see now that in both of these 2 triangles, I have established the fact that I do have 3 pairs of corresponding congruent sides. And since I'm looking to make my final statement here that the triangles are congruent, the fact that I have those 3 pairs of congruent corresponding sides indicates that I'm going to be able to say those are congruent by side, side, side. That's not to say that there's not a way of doing so with side, angle, side, but remember, part of this is that you're trying to follow the logic of the proof in front of you, not the proof that you would like to do. There are some instances where you're asked to do a proof that you would like to do, and you might have more than one option, and by all means, make sure that you explain that, because there's different routes you could take on a lot of proofs. So, and that kind of gets me into the last one, which is also a proof. This one here gives you a little bit more leeway because there's different things that can be done here. So what I'm about to show here is one way of establishing that. This one here, I mean, even though there could be other ways you could do so, there's not a whole lot you could possibly do with the information, but I'll kind of explain as I go along the way about, like, which one might be able to, where you could possibly go in other directions to do the same thing. So you're told that you have a rhombus ABCD with all 4 angles being congruent to one another. So I'm drawing the figure ABCD as a rhombus with all 4 angles being congruent. Now I'm purposely making it look like a rhombus at this point. I want to prove it's a square, but I don't want to draw it as a square and then say, hey, it looks like a square, and therefore it's a square. That's what some students do on this one. On one similar to this, say, hey, I drew it as a square, so it's a square. Well, that's not a proof, okay? I got to use information that I actually do have, and characteristics of a rhombus would be helpful as well. I do know that the measure of angle A plus the measure of angle B should equal 180 degrees. And that's because consecutive angles in a parallelogram, which a rhombus is a parallelogram, should be supplementary. I also know from given information they're congruent to each other. So by given information and the definition of being congruent, the measure of angle A is the same as the measure of angle B. Therefore, by substitution and simplification, I could say, I can come back to this first one right here, and say, okay, well, I can replace this with another measure of angle A, and therefore I have the measure of angle A plus the measure of angle A equal 180. That's 2 measures of angle A equaling 180. And when I solve that little equation by the division property of equality, I'd get the measure of angle A is 90 degrees. So I know that A is 90 degrees. And since all 4 angles are the same, being congruent, all 4 of them are 90 degrees. That means they're all 90 degrees, they're all right angles. And if they're all right angles, that would make it a square, because I already know it has the characteristics of a rhombus. If they're all right angles, that gives it the characteristics of a rectangle. And therefore, by essentially, what a square is defined to be, it's a square. And that, again, it's more like along the lines of the definition of a square. So you notice I was able to redraw the figure at that point because I could make them right angles because I knew for a fact that they were. I could have also used, all four angles being congruent, and I know the four angles should add up to be 360 degrees because of the angle addition postulate, so I could have went that route. Again, there's different routes you could have taken on this. This just happens to be the route that I showed. So that's the end of this review here. If you have any particular questions, please make sure you get in touch with me. And we could go over any additional information you need, and hopefully this gives you an idea of what you know well and what you might need to bone up on before you take the test. If you have any questions again, please make sure you do get in touch with me. But until I get to see you in a live lesson, or if I have a chance to speak to you on the phone, I will see you around. Have a good day.